Hi, my name is Carter.
And my name is David.
And today we're going to be looking at temperature sensors and throttle position sensors. So before we test any throttle position sensors on any lab vehicles, we are going to test the resistance of our throttle position sensor. It has 3 wires coming out of it, so we're going to be testing using the low reference and the signal. The black wire is our low reference and the green wire is our signal wire. And as we open and close the throttle body, we should see our resistance slowly increase to around 5.7 kilo ohms. And then it'll slowly decrease as we close the throttle body back down to about 0.8 kilo ohms. Next, we're also going to be measuring the resistance and bench testing this accelerator position pedal. So we have a diagram here for the pins. So pin 1 would be the VREF1, pin 2 would be the signal wire, pin 3 would be the return, and then 4, 5, and 6 would be the same thing for the second sensor. There are 2 sensors within this pedal. So I have my black wire hooked up to the VREF, and I have my green wire hooked up to the sensor 1 wire. So with this connected, we're reading about 1.8, 1.9 ohms, and we will adjust the accelerator pedal. Oh, like it's increasing to about 1.6 kilo ohms. If we let it close, it'll go back down to about 1.9 ohms. On this 2000 Buick LeSabre, we're going to be doing a sweep test with voltage, resistance, and we're going to be testing our pull-up, pull-down resistor. As we can see, pin A is a black wire and it's for the sensor return. Pin B is a dark blue wire and it's for the sensor signal. And pin C is a gray wire for the 5-volt reference. This is the wiring diagram for the vehicle. As you can see, we have our 5-volt reference going to the throttle position sensor. We have our sensor return going to the ground at the PCM, and then we have our sensor circuit wire with a pull-up resistor at the PCM.
Right now we're getting voltages and we're testing for point A on the connector right now. Yeah, it's resting at around 5 volts. And now we're going to do pin B, which is going to be our throttle position sensor signal. We're getting around half a volt. All right, now we have disconnected the TPS from our system here at the throttle body, and basically we're going to be doing a sweep test for resistance. And as we can see, we're starting at around 1.12 kilo ohms, and Carter's going to increase the throttle. And as he keeps his foot on the accelerator pedal and it's at full throttle, we're getting around 4.5 kilo ohms. All right, so right now we're going to be doing a voltage sweep test. We have our TPS connected and we're going to be looking at voltage right here as Carter puts his foot down on the throttle. All right, Carter, you can go. And as we can see, it dropped down to around 0.941, 0.942 volts.
So here we have the wiring diagram for the vehicle we're going to be using the picoscope on. These 2 blue wires, the blue and yellow and the blue and red, are for the throttle motor, which go to the PCM. And then here we have our 2 throttle position sensors. We're going to be connecting the picoscope to our battery ground and the white signal wire going into our main throttle position sensor. Now we're going to be using the picoscope on our throttle position sensor on this Suzuki SUV. We have our signal wire hooked up to the signal of our throttle position sensor, and then we have our other lead hooked up to the ground of the battery. So David's going to sweep the throttle. These are the voltage signal readings during and after using the use scope on the throttle position sensor. As you can see, we got near wide open throttle with around 4 volts and then dropped back down to almost 0. Here we have the engine coolant temperature sensor. Both sides of this are controlled by the PCM. We have the blue and black wire, which is the ground, controlled by the PCM, and then we have the yellow wire, which is the signal from the PCM. And here we have the intake air temperature sensor. It shares a common ground with the camshaft position sensor, and then the brown wire is the signal wire to the PCM. So here we have our engine coolant temperature sensor and our intake air temperature sensor readings. We're going to start the vehicle. As you can see, all of our voltages drop down to 0. And as the vehicle warms up, they should both increase about the same temperature. Here we have our temperatures. They're both at 58.2 degrees, and they're going to slowly increase. After back probing the ECT, we're getting a reading of about 0.033 volts with the key on, engine off. After back probing the intake air temperature sensor, we're reading about 3.2 volts. So to test our engine coolant temperature sensor, first we're going to locate the sensor. It's underneath our intake manifold. Then we're going to unplug it, and we're going to verify our PIDs of the vehicle. As you can see and hear, immediately the cooling fans kicked on. Right after I unplugged the ECT, we can see that the PID reading thought that the temperature drastically increased because there was a high resistance in the circuit with it being open. So when we pulled the air intake temperature sensor,
And when plugged back in, the reading went up.
the reading increased to about 120 degrees from 70 degrees. And when we plug it back in, our reading should drop back down.
And it's working, and now it's sitting there. Or it's not.